Audio Jungle. Audio Jungle.
Area, MAC relation. Okay, so one is called area velocity relation, that already you have seen, and this is called area MAC relation, which is very important. Okay, and area MAC relation you are going to develop for the D level nozzle or CD nozzle. Okay, D level nozzle or CD nozzle, you are going to develop the relation. Now check this. It's a very simple derivation only, and it is important as well. So I can say here this is the okay, this is what CD nozzle, right? And this is what throat. Convergent, divergent, and this part is nothing but constant area, minimum area, which is also called throat. Okay, so this one will be, here I can take flow in, and this is the flow out. Okay, where the MAC 1 at the throat, that area I am considering A star. What it is? A star. I will tell you what is the meaning of A star. Already I said that critical value where the MAC reaches to 1, quantity will be represented by star. Okay, so you can consider this is the throat, and where the area is what minimum, and it is constant area, and it is represented by A star. Why? Because MAC at the throat is what reaches to 1. Here MAC is nothing but, check this position. Obviously here MAC will be less than 1, and here MAC will be greater than 1. All right, I am going to consider this portion. Okay, this portion I am considering here. this is the one portion which is called area A1, and this is the another portion which is called A2, area 2. This is the another portion, area 2. Okay, so somewhere that portion I have taken, I can say this part here, this is what area 1, and this is the another part of the nozzle where the area is what A2, and this is what A star. Alright, this part called A star. I hope this one is clear to everybody. There should not be any confusion. It's very important derivation, and question based on this easily they can ask. Okay, so now what need to do? We need to develop the relation between the area A1 A2, or you can say A1 A star. Obviously, once we know A1 A star relation, then we can get A1 A2 relation also. Okay, how to do that? So I can take any two reason. One I will take at the throat, another we can take convergent or divergent, any one reason I can take. Okay, so and need to apply the Bernoulli, need to apply that mass conservation continuity equation. Okay, so now I can say apply continuity equation between any 2 points in the nozzle, in that one point must be at throats. So what will be the continuity equation? Check. It is nothing but rho a v, rho a v. One I am going to take at the throat, so just say throat value will be star. Yes or no? It's just star value. This is what throat. Any point in convergent or divergent section. Okay, all right. Why it is rho star and A star and B star here at the throat? That reason I told you, it is Mach 1, which is called critical value. Okay, and critical value, it is already explained what are the critical values. Somewhere you are considering the flow reach to sonic flow, and you are considering Mach is equal to what, 1. Okay, then it will give the special characteristics of the flow, which is called critical values. Okay, Mach will be called critical Mach number, pressure will be called as a critical pressure, temperature will be called as a critical temperature, and density will be called as a critical density. All right, now see here. So now we need to just segregate the this formulation. So how we will get from the same, you can write, we are interested to write the relation between areas. So a by a star I can write here. Check what is the a by a star. It will be a by a star. So it will be a by a star, it will be rho star by rho into v star by isn't it? Or you can write rho star by rho into V star. That time I told you what is the m is nothing but V by A. Yes, if I say V star, so V star means what? M becomes 1, then what will be velocity? It will be V star. So V star by A. So V star is nothing but A. Yes or no? V star is nothing but A. Okay. So what is the V star? It will be A divided by V. Hope you understood this. Yes or no? And because this is the V star, so at that same time, because there will be confusion like speed of sound at what conditions. So speed of sound at m is equal to 1, it will also be represented by A star better. So this V star will be A star. So whenever if you check the A star meaning itself is somewhere the speed of sound where Mach becomes 1. So better you just represent this speed of sound also by the star quantity. So it always recognized you like, okay, speed of sound where the speed is Mach number is what? 1. Alright, so what you got? A by A star. Here you got, this is nothing but A by A star is equal to, check, it's a rho star by rho star by rho into A star by V. Okay, again another manipulation, because you don't have any relation between rho star and rho, but one relation you have which is called rho star by rho naught. This relation you already have, so I have divided by rho naught and just multiplied by rho naught, sorry, just multiplied by rho naught, and this rho is already in denominator, so this rho I can write here, and this is nothing but A star by V. Alright, we know what we know, that formula, simple. That formula we know, which is nothing but rho naught by rho. What is this? This formula is nothing but, if you remember, 1 plus, this is the isentropic relation, 1 gamma minus 1 by 2 m square to whole power 1 by gamma minus 1. At the same time, if I will write rho naught by rho star, then this m will be 1, so it is 1 plus gamma minus 1 by 2, okay, into 1 square to whole power 1 upon gamma minus 1. What is rho naught by rho star then? If you solve this 1 plus gamma minus 1 by 2, it is gamma plus 1 divided by 2 to whole power 1 upon gamma minus 1. Yes or no? Now, this one result, rho star by rho naught by rho star, or rho star by rho naught. Now you can get rho naught by rho, also called this relation, which is isentropic relation basically, and rho naught by rho star, both value you achieved here. See, you can keep here. Now what about A star by V? How to get it? So this is simple. I can write M star, which is called critical Mach number, sorry, not critical, characteristics Mach number, sorry, it's corrected. This is called characteristics Mach number. Characteristics Mach number. So M star is nothing but what it is? It's a V by A star. Okay. And also I had given the relation which was called relation between m star and m. Already I had given this relation, if you remember. And what was the relation? Check. This relation was m star square is equal to gamma plus 1 by 2 m square divided by 1 plus gamma minus 1 by 2 m square, or you also can write gamma plus 1 m square divided by 2 plus gamma minus 1 m square. Yes or no? So what is the m star square? It is gamma plus 1 m square divided by 2 plus gamma minus 1 m square. This value you need to remember, okay? It's very special. All right, now you can use this relation. So this is what characteristics Mach number. What it is called? It is called characteristics Mach number. Okay. Now we can go for the previous. What was that? It was A by A star is equal to, it is rho star by rho naught, rho star by rho naught into rho naught by rho, and it was A star by B. Now you can keep all the value, right? So what you will have, check. I can do one thing just for simplification purpose. So it will be what, A by A star whole square here. Then this will be what, rho star by rho naught whole square. Okay, rho naught by rho whole square, and this is what, A star by V whole square. Why I am doing this? Because this A star by V is nothing but, A star by V is nothing but, it is m star, and we have m star square formula, so better you just square both sides, no? So now what you will get, check. Now I am just going to write the final. A by A star is equal to, just keep all the value, rho star by rho naught. What is rho star by rho naught? Check. Rho naught, rho star by rho naught is nothing but, sorry, rho naught by rho star is nothing but gamma plus 1 by 2 to whole power 1 upon gamma minus 1. Okay. What will be the rho star by rho naught? You just reverse the value. So what you will get? Rho star by rho naught. So gamma plus 1 by 2 as it is, you can if you want to write, you can write, and the power will be minus 1 upon gamma minus 1. Yes or no? So here you can write, okay, because you need to reverse the value. Okay, here if you check, this rho naught by rho star is nothing but gamma plus 1 by 2 to whole power 1 upon gamma minus 1, no? Then what will be the rho star by rho naught? You just reverse the value. So I will write here it will be 1 by m star. Okay, let me check that formula. Maybe a star by v, right? A star by v, it's a 1 upon m star, correct? Because m star is v upon a star, so a star by v is nothing but 1 upon m star. So a star by v we have, so it will be 1 by m star, right? Now keep the value here. So what we have, check rho star by rho naught. So rho star by rho naught will be 1 upon gamma plus 1 by 2 to whole power 1 upon gamma minus 1. Okay, this is the rho star by rho naught, and we have a square, so we can keep a square here. Okay, into rho naught by rho naught by rho. So rho naught by rho we already have 1 plus gamma minus 1 by 2 m square to whole power 1 upon gamma minus 1. This is also square, keep here, and then we have a 1 upon m star square, right? This is a star by v, which is nothing but a star b by a star by v is nothing but 1 upon m star. So I can write 1 upon m star square, because it's also whole square, so you will get this. Now keep all the value m star square, this is the m star square, no? This value you just keep all that, solve it. Final result I need to write here. Hope you understood this. Now I will write, or all this calculation you can do by your own, or you just remember the formula, that's all. A by a star, if you solve everything, then you will get 1 upon m square. Okay, 2 upon gamma plus 1 in bracket 1 plus m square, okay, to whole power gamma plus 1 divided by gamma minus 1. This is the formula you all need to remember, and this is very special formula. Okay, this is very special formula. Now as I told you, we have to solve few numerical also based on it. So this is the result you got here. Okay, this is the final, or also you can write another way, or a by a star. Now you can write what is the a by a star, take the root of it, so 1 upon m square will be 1 upon m. Okay, in root it is 2 upon gamma plus 1 in bracket, what is this, 1 plus okay, and the whole power will be, once you solve, then you may get the whole power will be gamma plus, because you have taken the root of it. So earlier it was 1 gamma plus 1, then gamma plus 1 divided by 2 upon gamma minus 1. Okay, this is the result, final result you need to remember. Okay, one conclusion I will tell you, check, we have m star m square na, just try to connect this. Wherever the area A is, there the flow will be the flow Mach number will be m. Okay, I can show you what is the mean of it. Check, this is the nozzle. Okay, as I told you, this will be what, here the area will be A star, or in few books you may get ATS, throat area. So here obviously it's a star, so your Mach number will be m star, and that m star value will be 1. Then wherever the area A you are taking, suppose you are taking here this area, okay, suppose you are taking, this is the area, all right, this is the area A, then here the Mach, this m will be Mach of flow at this portion. And if you are taking area in the convergent, so that time Mach will be in convergent. If you are this taking this area in divergent, then this Mach will be in divergent. So here you can say, based on this analysis, you can say how many Mach number you will get. 2 Mach number. One will be subsonic, another will be supersonic, because if you check here this Mach number, it will be less than 1, means subsonic, and here the Mach number will be, this is divergent, here the Mach number will be m greater than 1. Okay, so it depends on the area, what area you are taking, based on that you will have Mach number. If you are the area taking area in the subsonic, okay, if you are taking here, this is the area, suppose you are taking, okay, so this is in convergent section, so here the Mach will be what, subsonic. If you are taking this area in divergent, so here the Mach number will be greater than 1. Yes or no? So based on this, you can say the points I must write. What is the point? We can write based on A by A star. Okay, based on A by A star, there are, we have two values of Mach number. What are that? Subsonic and supersonic. Subsonic and supersonic. Yes or no? How to get it? So if you want to write along the nozzle, if you want to draw the area, this is along the nozzle. Okay, along the nozzle. Along the nozzle area will be what? A by A star. So here we will have Mach number. What is the Mach number? Mach number will have a 2. Okay, one will be okay. So here m will be, you can say, less than 1. Here m, I must say, greater than 1. Okay, all right. Subsonic and supersonic. Subsonic and supersonic. Okay. At this, here the m is equal to 1, hence At this point, A by A star will be 1. Okay, you can check here. If you keep m is equal to 1, okay, if you keep m is equal to 1, then this A by A star will be 1. You can check m is equal to 1, then it will be what, 2 plus gamma gamma minus 1, which is nothing but gamma plus 1 by 2. So inside bracket gamma plus 1 by 2, outside bracket 2 upon gamma plus 1, cancel out, whole power nothing. What happened, whatever the power of that, 1 doesn't matter, it will be 1 only. So A by A star will be 1. So this is the point where, okay, this is the one objective also, like what will be the value of A by A star. Okay, value of A by A star. Okay, so at m is equal to 1, A by A star will be 1. You need to connect this relation. Okay, so they can ask also. Always remember, whatever the analysis you have done in CD nozzle, last class I had shown you 4 cases: case 1, 2, 3, 4. Case 1 was total throughout the CD nozzle, subsonic. Case 2, just choked, means at the throat Mach number reached to 1. Then case 3rd was shock wave recognized inside the nozzle, and fourth case was shock wave existing at the exit of nozzle. 4 cases. So this is the all the analysis what you have seen for the CD nozzle up to here. This is for the isentropic. So even though this relation itself it is valid for isentropic. If somewhere shock is what you are getting, then this relation will not be valid. Okay, isentropic flow only. This is valid for isentropic flow only. Okay, now now I'm considering, for my case I'm taking A1 and A2. Suppose I have, this is the CD nozzle, here it is A star. Okay, here it is this is what A star. I'm saying here area is what A1 and here area is what A2. At area A2, what is the Mach number? It is M2. Okay, and at just hold on. Here the Mach number is, it is all right. So what will be the relation? So you have to check this, and just directly I'm going to write, just reconnect that previous formula what you have. It is A by A star. I can write A2 by A1. So this m will be reciprocal and this m is directly proportional. So I can write here A2 by A1. If you are wishing to write A2 by A1, then so just reciprocal, because this Mach number outside the bracket it is the reciprocal. So A2 by A1 if I am writing, so it will be M1 by M2. Okay, and then this bracket we will have 2 upon gamma plus 1, 1 plus gamma minus 1 by 2. It is A2, hence it is M2 square. It is A1, hence it is 1 plus gamma minus 1 M1 square. In bracket gamma plus 1 by 2. Okay, always remember dear. So this will be useful, very useful sometimes. They will give to you that area A1, A2. They will give the Mach number, one Mach number they will give to you that time. Another Mach number if you want to calculate, then you can use this formula. Okay, important. All right. This should be very clear, no? Okay, sometimes the formula also your A1 A2 now it is clear where is the A1 where is the A2. I told you A1 A2 I can take a different maybe this is the one reason where area is what A1 and this is the another reason where the area is what A2. Okay, for that this is the formula. Now suppose you have this CD nozzle like this, all the formulation will be very useful. Okay, once you solve the numerical, if you do this much, I'm sure any question you can solve. Okay, so but the condition is you should remember the formulation A star and another exactly at the exit A. So what will be the Mach number here? Because it's a exit, I am considering here exit, so Mach number will be ME. What is the M star here? Obviously M star will be 1. Now I am interested to write this in terms of exit Mach number, then what will be the formula? So I can write A exit divided by A star and this formula will be 1 upon ME, okay, in bracket 2 upon gamma plus 1, 1 plus gamma minus 1 by 2 ME square to whole power gamma plus 1 to gamma minus 1. This is also very important. Okay, the same thing I am writing. Don't remember all formula, only one formula you need to remember here. That's all, that master formula. Rest you can write by your own. The same formula whatever I have written here, see A by A star, check A by A star. This is the formula. You remember this formula only. If you remember, this is the master formula, no? If you remember this, then you can write this A1 by A2 also, or A2 by A1. You can write this A by A star also. If you remember, see, if you say this A is exit area, then this M will be exit Mach and this M will be exit Mach. That's all. That's only I have written here. Check here. A I have written A exit, hence this Mach will be exit Mach number. That's all. Okay. So with the help of what is the conclusion point? That conclusion point you will have two Mach number. One will be subsonic, another will be supersonic. Depends on your area, what area you are taking. Okay. So for each value of A by A star, you will have a two Mach number, and that will be that Mach number will be correspond to it is in convergent or it is in divergent. If it is in convergent channel, it will be subsonic. It is divergent channel, it will be supersonic. This formula will be valid for isentropic. It will, I mean, this formula you cannot see. I will tell you somewhere. Okay, another diagram better. No, if this is the CD nozzle. Okay, in this CD nozzle, if A star and here the shock wave is what absorbed, and this is what this is the exit area AE, okay, and this is what shock, and here you can say the flow we have here, the flow will have, and this flow is nothing but Mach number is ME. But at the same time, it is observed that in divergent channel you got normal shock. Normal shock or any shock. Always remember, in convergent divergent only normal shock will be formed. Okay. So then A by A star, this formula 1 upon M to whole power 2 upon gamma plus 1 plus gamma minus 1 by 2 m square to whole power gamma plus 1 divided by 2 gamma minus 1. Okay. Will this formula, in this condition, this formula will not work. Means point. What is the point? Across normal shock. Across normal shock, A by E star formula will never work. Okay, always remember what, that's the reason I have especially mentioned this is valid for will never work. It is valid for isentropic, and once normal shock is what absorb here, so it will not isentropic flow anymore because shock is what absorbed. So this formula will not work here. So this formula will not work. This formula will not work. Yes or no? All right. Fine. So this is all about CD nozzle. CD nozzle also, like, because of the time constraint I'm not able to continue this. Otherwise, it again, if you go for the CD nozzle analysis again 1 more hour it will take. But what is required for your gate, that is I explained, and that is more than enough. No need to go for more and more, because this is the CD nozzle. This is the very great thing, and that many analysis for this CD nozzle we have in books. If you read properly, then you may get that also. But I think till now, with the help of diagram, different diagram, everything I have explained what was required for your gate. Now we'll solve numerical. Okay. Now we'll solve numerical. All right. We can write the jet velocity also. No? Jet velocity from the reservoir. I'm considering jet velocity, or you can say it is exit velocity from CD nozzle. So this is the same like from reservoir, but I'll explain you with the help of diagrams. It will be more clear to you. Just say this is what CD nozzle. Rest, once we'll solve the numerical, then we'll able to understand everything. But okay, I'm taking one example. So this is what CD nozzle, and exit velocity I'm interested to calculate. So what is the velocity here? It is exit, because this is nothing but exit of CD nozzle. So if this is the exit velocity, then what will be the Mach number? Mach will be m exit So how to get it? Okay, so for that, and what will be the temperature here? Obviously temperature will be TE, because it's the exit point. Exit point. How to get the that velocity? So one thing should be very clear, because here we have an inlet. This is the inlet. So obviously the temperature will be T, and the Mach number will be M here. This is what inlet. Just try to concentrate inlet. Okay. Temperature will be T, Mach number will be M, and velocity will be because that time you might be knowing that what is the flow velocity and exiting condition. Sorry, inletting condition. I mean the flow is what going inside the nozzle. So that condition you must know, like what is the temperature, what is the Mach number or velocities or density, pressure, everything you should know. Okay, so that condition we can calculate total temperature. What we can get? Total temperature. So total temperature, that time we should know how to get total temperature. How to get this? It's very simple. Total temperature will be what? T naught is equal to T, okay, plus V square by 2 Cp. Okay, this is the value. Total temperature, this is called static temperature, this is the velocity. So anyhow, even though they have given the inlet temperature, okay, so this is the atmospheric temperature, or you can say inlet temperature, it's your choice. If you say, because T naught is the total temperature, this is the inlet temperature, Vi plus sorry T I got Vi plus Vi square plus 2 Cp plus Ti. This reverse I have written, no problem. So my point is, you should know total temperature, and this total temperature will be constant throughout the, in fact, whatever the total temperature, this total temperature, the same temperature, total temperature will be here also throughout the nozzle. It is not going to change. Why? Because this is the stagnation quantity, and I told you, like, even though shock is also formed, because till now I have not explained normal shock, but even though shock is also formed, but total temperature must be constant. Total temperature must be constant. It is not going to change. When the shock is moving, then total temperature will be changed, but total temperature will not change when even the shock is formed inside the CT nozzle. Okay, so once you know the, but here what I'm explaining, this formulation and all, I'm explaining isentropic. There is no shock formation, so this T naught must be constant. Okay, so once you know the T naught, so this T naught, now because this T naught you got from where? From the inlet condition. From the inlet condition you have calculated T naught. Okay, or you can apply this formula T naught by Ta. A is the inlet, this is the inlet or atmospheric condition. Okay, atmosphere condition. So here it is denoted by A, Ta. So what will be the formula for isentropic? 1 minus gamma minus 1 by 2 Ma square. This is the formula. The inlet Mach number, which is at atmospheric condition, so this value, it is known to you, and you have calculated T naught. This T naught will be constant throughout the CD nozzle. Now you want exit velocity, so how you will do it? So what formula you have written? This is for the inlet. Okay, this is for the inlet. Now for exit, what will be the formula? The same formula you can write. T naught, because T naught is constant throughout inlet and exit. T naught is equal to, instead of Ti, I can write T exit, plus instead of V inlet I can write V exit square divided by 2 Cp. Yes or no? Now if you want to calculate V exit, so what will be the V exit? It is 2 Cp T naught minus Te. Again, this, if you want to calculate, you can calculate this exit velocity in terms of pressure also. You can convert this T naught and Te in terms of pressure also. So when I taught reservoir, so that time I explained this velocity in the form of what it is called, in the form of pressure, pressure ratio and all. It is already explained. So this is the one formulation for the exit velocity. Remember, this is what the exit velocity. Okay, here it is nothing new, already in reservoir I have taught. So this is the first question based on CD nozzle. Okay, so this is like types of the similar kind of gate question, but here many value will calculate, but in gate exam they will ask only one or two value maximum. But here we are going to calculate more number, more values, so don't bother about it. Okay, so much lengthy question, how they can ask? No, they can ask, but the thing is they will ask only one or two value. Okay, and now so listen. This is air, please write this question: air from a reservoir, air from a reservoir at 10 atm and 80 degrees Celsius is discharged through a CD nozzle fitted to the reservoir, fitted to the reservoir. Okay, the thrust exerted by jet issuing from the nozzle is 11.12 kilonewton. Okay, if the back pressure is if the back pressure is 1 atm, calculate. Okay, calculate nozzle area, throat area. Okay, throat areas, okay, and and the Mach number of the jet issuing from the nozzle, and Mach number, ME, you can say issuing from the nozzle means ME. Okay, assuming, this is the assumption, assuming flow through flow through the nozzle is isentropic and correctly expanded. This type of technical word will come. So already I have told you what is the under expansion, over expansion. Okay, correctly expanded they have given to you, right? This is the question. Now we'll mark all the important value here. See what they have given to us. We'll mark all the important values here. It is nothing but reservoir they have given, so they have given reservoir, so all the value here, it is total value. If I say this is 10 atm, so it is pressure which is nothing but 10 atm. I told you reservoir means The velocity or flow of the fluid assumed to be zero, hence all the quantity inside the reservoir will be given. It will be given total quantity. So temperature will be P naught, which is nothing but 80 degrees Celsius, but convert into Kelvin. So you may get how much it is? 353 Kelvin. One thing clear, okay? And this CD nozzle is what fitted to the reservoir, okay? The thrust exerted by the jet engine also they have given from the nozzle is 11.12 kilonewton. This is also very important. And the back pressure they have given 1 atm. Okay, you have to calculate nozzle area, throat area, and ME, which is the exact Mach number of the flow of the fluid. Okay, or you can say air or gas. They have said the flow is what inside the nozzle. Isentropy means they have clearly mentioned, or it is cleared now, there is no shock formation because inside the nozzle flow is isentropic. And one very special word they have given, correctly expanded. Okay, so how many types of the expansion I have told you? Expansion in nozzle. Okay. Because this word you should very clear about it. Okay, one was under expansion, over expansion, and third is fully expansion. Okay, fully expansion, or it is also called correctly expanded. Okay, or correct expansion. So what was the under expansion? Under expansion means still pressure is available to expand. So that means whatever the exit pressure, it is under expansion. Okay, exit pressure is greater than back pressure. Over expansion means the extra pressure is what extra expansion was there. Expansion means reduction in pressure, so extra reduction in pressure compared to the back pressure or atmospheric pressure, hence PE is less than PB. Okay, over expansion means extra expansion, you can say, or extra pressure drop, called over expansion. Under expansion means it is yet to expand, so means pressure is available now, extra pressure you can say available. Okay, and correctly or fully expanded means PE is equal to PB. So question, numerical question they are asking. Okay, many numerical question based on this they are asking. They will use the word fully expansion or correctly expansion, so that means E is equal to PB. This both are theoretical question here. Okay, you are not able to solve question based on this, but theory question they will ask to you, theory, and this is the numerical point of view. Okay, numerical point of view, this is very important. All right, so we'll write all the given data first. What are the given data? P naught, please write all the value here. P naught 10 atm, P naught is 353 Kelvin. Okay, and for fully expansion, PE is equal to PB, and back pressure also they have given to you how much? It is 1 atm. Back pressure check. It is 1 atm. These are the given data. Okay. From with this given data, what you can calculate? P naught you have and PE you have. P naught by PE you have. Okay, what you can calculate from P naught by PE? Anything else they have given to you? That is okay. What is the P naught by PE? Because it is isentropics, you can apply this formula: 1 plus gamma minus 1 by 2 me square to whole power gamma upon gamma minus 1, right? 2.15. So what is the exit Mach number from this formulation? If you do, then exit Mach number will be 2.15. This is what supersonic. Okay, so now we can draw one CD nozzle as per given problem. This is connected with the reservoir. Okay, P naught they have given to us, and here at the exit of nozzle Mach is ME, which is nothing but 2.15. So obviously here Mach less than 1, here M greater than 1, and exit is 2.5, right? This area will be exit area AE, and this will be, obviously it is M less than 1, here M greater than 1, so this will be what? M is equal to 1, which is nothing but A star. And if somebody will ask you, it is choked flow or not? Yes, it is choked flow. Choked flow means what? Once Mach number reach to sonic flow at the throat, then you can say it is choked flow. Okay. So whatever the mass flow rate you will calculate here for the choked flow, always it is maximum mass flow rate. Okay. I think Mach it was 2.15. No? Let me check. Mach is 2.15. Sorry, just correct it. Okay. So fine. This is the actually real problem, you can say. CD nozzle exit Mach number you achieve 2.15. Now what you have to calculate? You have to calculate the throat area, and what you have to calculate? Exit area. How you can calculate it? It's very simple. Now because you have this value of what it is called exit Mach number, so with the help of this you can calculate. Now what how you can calculate this? Simple, that area velocity rule. No? Area Mach number, sorry, area Mach number rule or area Mach number relation, you know very well. So area Mach number relation, area Mach relation. What is the area Mach relation? I told you it is A by A star. What was the formula? 1 by M, 2 upon gamma plus 1. Yes or no? 2 upon gamma plus 1 in bracket. It was 1 plus gamma minus 1 by 2 M square. Okay, to whole power. This is the value. Okay. Now you are going to write this as a exit Mach number. I told you the technique. So exit Mach number divided by A star will be what? 1 upon. Why you are writing A exit by A star? Because M exit you know, na? M exit just know you have calculated 2.15. So you can use A exit by A star formula. 2 upon gamma plus 1, 1 plus gamma minus 1 by 2, M exit gamma plus 1 divided by, you calculate this A exit by this formula. If you calculate, check. So here it is nothing but 1.91 I can say. This is what A by A star approximate value. If you go accurately 2 digit, then maybe data a little bit change, but yes, 1.91 I'm writing here. Okay. Once you got A by A star, here in the problem itself they are asking both exit area as well as throat area. Both they are asking exit area and throat area. So this ratio, whatever you achieved here, A by A star, that is okay. Okay. This is useful, but the thing is they are asking, both are unknown. AE and A star both are unknown. So anyhow, if you one data you know, then the other area you can calculate. I mean, if you know throat area, then you can calculate exit area. If you know exit area, then you can calculate throat area. So check any other data they have given to you. So one thing is very nicely they have given. They had said nozzle thrust they have given to you, thrust. So obviously thrust, I cannot say it is T because it is the thrust, otherwise T means exit temperature. So thrust they have given to you, which is nothing but 11.12. So this data they have given 11.12, you can say thrust, how much? 11.12 kilo. We will use this, yes or no? I had told you that uh, what it is called, the how to calculate the exit velocity, yes or no? So if you know what is the exit velocity, then thrust area will, I mean thrust will be easy to you to calculate the value. So what is the exit velocity? Exit velocity from CT nozzle. So here I had given the formula, and that formula was, because if you want to use this the thrust, so for that reason you can because if you write the thrust formula for the CD nozzle, then I will tell you pressure will also come, but in that if you go, then pressure will be cancelled out. Why? Because it is fully expanded, no? So exit pressure and atmospheric pressure will be same, so that value will be cancelled out. So that is the one way to calculate uh, exit area. Otherwise, one more thing you can, if you think about it, then you will understand. I have given here this throat is what choked, and throat is what choked, then mass flow rate will be maximum. That is also correct. So maximum mass flow rate from the CT nozzle or reservoir we had seen. Okay. So if you use that formula, then also throat area you can get. Once you get throat area, you can get exit area. Otherwise, you calculate exit area, then you calculate throat area, because ratio you have. See, so both way we can go. Okay, both way we can go. Check this exit area and throat area ratio we have. So one we can calculate exit area. Another what we have, we can calculate throat area. So both I think we should do. Okay, and we'll check the result. So exit velocity from a CD nozzle. So how to get it? So it is nothing but VE is equal to, what is the formula? 2 Cp P naught minus T exit. Yes, this is the formula now. Yes or no? This is the formula now in root. Okay. And once you get the V exit, we can write thrust formula from the nozzle. That I will write. So now we have that ratio. Okay. What is the ratio we have here? that formula of T naught by TE is equal to 1 plus gamma minus 1 by 2 ME square. T naught we have. What is the T naught check? T naught is 353 and what is the ME? 2.15. So 353 divided by TE 1 plus gamma minus 1 by 2. ME is 2.15. If you solve T exit you may get. It's a 183.4 near about, no? If little bit variation also possible, but approximate this value you may get because it is expanded. Okay, all right. Now check. So T naught we have and CP because gamma air you have taken. You are taking gamma is 1.4 and CP also you can say it is air. So that time I told you 1005 joule per kg Kelvin, or also I had said 1.005 kilojoule per kg Kelvin. This is the data, no? You can calculate exit velocity. 2 Cp T naught you have minus Te. If you do this, you will get VE 583, or I can say 584 meter per second. Okay, this is the exit velocity. Now you are going to write the thrust. So thrust equation. Yet I have not derived the thrust equation for the CD nozzle. I will derive it in the that jet propulsion topic. But I can, in short, I can give the formula. Okay. So this is the CD nozzle. It is given. Now check there. So this is the back pressure, which is the, and here it is exit pressure. Okay, PB it is given 1 atm. All right, AE exit area, and we can say the mass flow rate. It is nothing but m dot. What is the mass flow rate? Rho. Okay, E area E, V exit E, rho AV. All right. Now if I will write the thrust equation, in short I am writing. I am believing that you know already this formula, okay, but this formula will be derived in jet propulsion subject. So thrust will be m dot mass flow rate into basically velocity, okay, plus exit pressure minus back pressure or atmospheric pressure. I can write exit minus atmospheric pressure, here it is given back pressure, into exit area. This is the formula. So here they have given, what they have given, PE is equal to PB. They have given to us because it's a fully expanded case. I can say this part will be 0. So what is the thrust? M dot VE. Yes or no? And in M dot, what they have given to us? Mass flow rate rho E, AE, VE into VE. Yes or no? Now I can say thrust, which is nothing but rho e AE VE square. What is the rho e? It is PE by RTE, exit area, velocity square, and thrust. Okay. What will be the area A exit? Thrust they have given to us how much? I think 11.12 kilonewton. 11.12 kilonewton. So 11.12 kilonewton 10 power 3 divided by, what is the PE they have given? I mean, you have calculated something, I think. You have not calculated. PE is PB, na? 1 atm. 1 atm they have given already. Take it. 1 atm. 1 atmospheric pressure means 101.325. Okay. Divided by R for air is nothing but 287. Already I have told you in my previous lectures. TE temperature, exit temperature you had calculated, it was TE, it was 183.4. Okay. And VE, what is the velocity VE you have calculated? VE 584. We'll find this. So here you got 0.0169 meter square, or you can write 169 centimeter square. Okay. Once you got exit area, then throat area you can calculate. How? They have given AE by A star 1.91. AE by A star 1.91. So exit area you got. What is the A star? It is throat area, and throat area is nothing but A by 1.91. What is the exit area you got? 169 centimeter square. 1.91. If you do this, my calculator, 169 divided by 1.921, how much? It's 88.48. So you got A star, which is nothing but throat area, 88.48. Okay. This is your answer. So this is your answer. But I will tell you, like I told earlier also, there are two ways to solve this question. Okay. How? Because one very good application, and that I also want to show you. What is the good application here? The Mach number in the divergent section is 2.15. That means it is m greater than 1. That means because exit is Mach greater than 1 supersonic, it means in convergent it was subsonic. It means at the throat it was m is equal to 1. When m is equal to 1, then there it is called choked flow, and that choked flow, at the time of choked flow, mass flow rate you will have maximum. This concept you use and cross check your answer. Okay. It will take hardly 5 minutes, but you will be the happiest person once you cross check the answer and if you are getting the same. That usually always happens. Okay, so we'll do here what we say. As we know, as we know the flow is choked. Why? Because you are at the throat, you are getting m star is equal to 1, and when you are getting m star 1, it is called choked flow, and that time you will get maximum mass flow rate. So and we know that maximum mass flow rate formulation already we had seen. Maximum mass flow rate I had given that time. What was the formula? 0.6847 divided by this formula already given to you previously. To go and check your notes, it is given. I had derived this maximum mass flow rate P naught, and it was ATH throat area. So we'll use this. Okay, and we'll get the throat area here. How you will do it? It's very simple. Now I will go fast little bit because already answer you got. Now we are cross verifying. So first you will calculate the mass flow rate. How you can get this? Because the nozzle is what fully expanded. So for fully expanded nozzle, fully expanded nozzle, for fully expanded nozzle, for fully expanded nozzle, that thrust will be what? I told you that mass flow rate into exit area, and that pressure term will not be here because it is fully expanded, so this value will be 0. Always remember. So whatever the mass flow rate you will get, it will be the maximum only thrust by velocity. You already have seen thrust is 11.12 kilonewton 10 power 3 divided by exit velocity. Also you have calculated. It was I think 583 somewhere you have calculated here. 584, 584, 584. If you check this, let me calculate. 11.12 power 10 power 3 divided by 584. Here it is 19.04 kg per second. This is the mass flow rate. And remember, because the nozzle is what choked, so this is the maximum mass flow rate. We have maximum mass flow rate formula MACH. What is that? It is 0.6847 divided by root of RT naught, throat area, into P naught. So we'll get, because this maximum mass flow rate just now you have calculated how much. It is 19.04. Okay, we'll get this ATH. ATH is nothing but 19.04 into R. 287 into what was the T naught? It was 353 if you check, and rest will be in denominator. So 0.6847 into P naught. P naught was 10 bar if you remember. 10 bar. Okay, so 10 into bar, 1 bar means 101.325. If you calculate this ATH, so let me check how much it is. 287 into 353, take root of it, multiplied by 19.04 divided by 0.6847 into 10 into 101.325. put in box. We are getting 8.735 into 10 power minus 3 meter square, or if you convert in centimeter square, so just multiply by 10 to power 4. So how much you may get? 87.35 centimeters. Okay. 8 years by, check what is the A star by, what is the ratio? AE by A star. AE by A star. A star means throat. AE by A star. What is the value you are getting? AE by 1.91. Yes or no? If you do this, so this AE, A star means throat. So what is the AE? It is throat into 1.91. How much? You are getting 87.35. 1.91. What is exit area? 10 to power 4 multiplied by 1.91. It's 1.91. What do I am getting? 87.35 into 1.91. It's a 166. 166.83 centimeters. Just cross check your answer. This is the exit area, okay, and this is the throat area by the another method. This is the second method you have used. Now check your previous method. A star throat area you got 88.48. Here you are getting throat area 87.35, which is very close. Doesn't matter. Exit area you got 169 centimeter square. By another method you got 166.83. It is also very close, you can say. It is almost close, so you can accept this. Or maybe sometimes if you have not fixed your calcium up to 2 digit, so because of that also sometimes there is the mismatch, little bit mismatch, not more than 5%, but yes, it is very close, you can accept it. All right.